Welcome back to Coder Beans. Ready to explore more about JavaScript? In our latest video, we're diving into Asynchronous Programming Part 3, where we'll uncover the magic behind event listeners and timers and intervals. What you'll discover: event listeners, learn how to make your web pages interactive by responding to user actions like clicks and keypresses. Timers and intervals. Dive into the world of timing events and discover how to schedule tasks to run at specific intervals. Event listeners. The asynchronous nature of event listeners is a key concept in web development. When an event occurs, the associated event listener doesn't interrupt the normal flow of the program. Instead, it is placed in a queue and executed asynchronously, allowing the rest of the program to continue running. Basic asynchronous example. In VS Code, create an index.html file. In index.html file, press and hold Shift key, click on one key and then press Enter. You will get this boilerplate code. Change title to Asynchronous Event Listener example. In body tag, write this code. A button tag with ID equals my button and button text, click me. In script tag, write this code. Const button equals document.get element by ID my button. Asynchronous event listener button.add event listener, click, function. Console.log event listener executed. Console.log program continues running. Click on Go Live in VS Code. You will get a button Click Me in browser window. Right-click in browser window and then click on Inspect. Click on Console to open the console window. You will see this program continues running. Click on button Click Me. You will see this event listener executed. In this example, the event listener is registered for the button click event. After registering the listener, the program continues to execute the next line. Console.log program continues running without waiting for a button click. When the button is clicked, the event listener is executed asynchronously. Event loop and callback queue. JavaScript uses an event loop to manage asynchronous operations. When an event occurs, the associated callback event listener is placed in a callback queue. The event loop continually checks the callback queue and executes the callbacks one by one. Example with asynchronous behavior. In index.html file, write exclamation sign and then enter. You will get this boilerplate code. Change title to example with asynchronous behavior. In body tag, write a button tag with ID equals my button and button text, click me. In script tag, write this code. Const button equals document.get element by ID my button. Asynchronous event listener. Button.add event listener, click, function. Console.log event listener executed. Console.log program continues running. Simulating a time-consuming operation. Set timeout. Console.log after 2 seconds. Console.log timeout completed. 2000. Console.log program continues running after set timeout. Output, program continues running. Program continues running after set timeout. After 2 seconds. Timeout completed. To see the output live, click on Go Live in VS Code. You will see a button Click Me in browser window. Right-click in window and then click on Inspect. Click on Console to get the console window. You will see this output. Program continues running. Program continues running after set timeout. After 2 seconds. Timeout completed. To To see the output again, clear the console window like this. First you will get program continues running. Program continues running after set timeout. Then after 2 seconds you will get this in console. After 2 seconds, timeout completed. In this example, the event listener is registered for the button click event. The program continues running and a timeout function is scheduled using setTimeout. The event listener and the timeout function are both asynchronous, and their execution order depends on the event loop. Asynchronous execution order. In index.html file, write this code. Write exclamation sign and click enter, you will get this boilerplate code. Change title to asynchronous execution order. In body tag, write this code. A button tag with ID equals a my button, button text click me. In script tag, write this code. Const button equals document.get element by ID my button. Asynchronous event listener. Button.add event listener, click, function. Console.log event listener executed. Console.log program continues running. Simulating a time-consuming operation. Set timeout. Console.log timeout completed. A0. Console.log program continues running after set timeout. Output in console. Program continues running. Program continues running after set timeout. Timeout completed. Event listener executed. Click on Go Live in VS Code. You will get a button Click Me in browser window. Right-click in browser window and click on Inspect. Click on Console to open console window. You will get this. Program continues running. Program continues running after set timeout. Timeout completed. Click on Click Me button, you will get this. Event listener executed. In this example, the event listener is registered for the button click event. The program continues running and a timeout function with a delay of 0 milliseconds is scheduled using setTimeout. Even though the delay is set to 0, the timeout function is still executed asynchronously after the event loop processes the callback queue. Practical implications. Understanding the asynchronous nature of event listeners is crucial for handling user interactions and asynchronous tasks effectively. It ensures that the user interface remains responsive even when time-consuming operations are in progress. Advantages. Responsive user interface. Asynchronous event handling prevents the user interface from freezing during time-consuming operations. Non-blocking. Other parts of the program can continue running while waiting for user interactions or asynchronous tasks to complete. Challenges. Order of execution. The order of execution for asynchronous code may not be intuitive, especially when dealing with events and timeouts. Callback hell. Asynchronous code with multiple nested callbacks may lead to callback hell, making the code hard to read and maintain. In summary, the asynchronous nature of event listeners allows web applications to remain responsive and handle user interactions without blocking the execution of other code. Understanding how the event loop and callback queue work is essential for writing efficient and responsive JavaScript code. Timers and intervals. Timers and intervals are mechanisms in JavaScript that allow you to execute code after a specified amount of time has passed or at regular intervals. They are commonly used for animations, periodic updates, and delayed tasks. SetTimeout function. The SetTimeout function is used to execute a specified function or code once after a specified amount of time. For example, write this code in script.js file in VS Code. Example using SetTimeout. Function delayed greeting. Console.log hello after 2 seconds. SetTimeout delayed greeting 2000. Executes delayed greeting after 2000 milliseconds 2 seconds. Output hello after 2 seconds. Right-click in VS Code and click on Run Code. You will get this output. Hello after 2 seconds. In this example, the delayed greeting function is executed after a delay of 2000 milliseconds 2 seconds. SetInterval function. The SetInterval function is used to repeatedly execute a specified function at specified intervals. For example, Write this code in script.js file in VS Code. Example using setInterval. Let counter equals 0. Function increment counter. Counter plus plus. Console.log counter, $counter. Executes increment counter every 1000 milliseconds, 1 second. Const interval ID equals setInterval, increment counter, 1000. Function clear. Clear interval, interval ID. Stops the repetition of the interval. Console.log setInterval cleared. Set timeout clear, 5000. Output counter 1, counter 2, counter 3, counter 4. Set interval cleared. Right-click in VS Code. You will get this output. Counter 1, counter 2, counter 3, counter 4. Set interval cleared. In this example, the increment counter function is executed every 1000 milliseconds, 1 second, and the counter is increment each time. We also used a clear function which we will explain next to stop the execution, otherwise it will continuously run and print after every 1 second indefinitely. Clearing timers and intervals. Both setTimeout and setInterval return an identifier that can be used to clear, cancel, the timer or interval. For example, clearing a timeout. Const timeout ID equals setTimeout. Console.log, this won't be executed. I2000. Clear timeout, timeout ID, cancels the execution of the timeout. Clearing an interval. Const interval ID equals setInterval. Console.log, this won't be repeated. I2000. Clear interval, interval ID. Right-click in VS Code and run code. You will see nothing in the output because both after setTimeout and setInterval you cleared it using timeout ID and interval ID. In these examples, the clear timeout and clear interval functions are used to cancel the execution of a timeout and stop the repetition of an interval, respectively. Practical example, countdown timer. In index.html file write this code. Write exclamation sign and then enter, you will get this boilerplate code. Change title to countdown timer example. In body tag write a dev tag with ID equals countdown number 10 which will be displayed in the browser window. In script tag write this code. Let countdown value equals 10. Function update countdown. Const countdown element equals document.get element by ID countdown. Countdown element.text content equals countdown value. If countdown value equals 0. Clear interval, interval ID. Alert, countdown completed. Else, countdown value. Minus. Const interval ID equals setInterval, update countdown, 1000. Update countdown every 1000 milliseconds, 1 second. Click on Go Live in VS Code. You will see this in the browser window. A countdown timer which is started with a number 10 and then decreases by 1 after every second. When it reaches to 0, an alert dialog will be displayed in the browser window. In this example, a countdown timer is created using setInterval. The update countdown function is executed every second, updating the displayed countdown value. The interval is cleared when the countdown reaches 0 and an alert is shown. Tips and considerations. Avoid heavy operations. Be cautious when performing heavy operations inside timers or intervals, as they may affect the overall performance of your application. Use Request Animation Frame for animations. For smoother animations, consider using the Request Animation Frame function, which is optimized for rendering animations. Consider clear interval condition. When using setInterval, ensure that there's a condition to clear the interval to prevent it from running indefinitely. Timers and intervals are powerful tools for scheduling tasks in JavaScript. Whether you need to delay the execution of a function or repeatedly execute it at intervals, these mechanisms provide flexibility and control over the timing of your code execution. Stay up to date with the latest coding tutorials, tips, and community discussions. Subscribe to Coder Beans and join us on our coding journey.